So we are taking our tutorials on chemistry for 4 months. In 4 months, we are starting with introduction to periodic chemistry. Okay, so first of all, let's define periodic chemistry. So periodic chemistry is the study of the variation of properties of elements with atomic numbers. So here we are going to study the properties of what? Elements based on what? Their atomic numbers. Okay, so now let's move on to our next subtopic, which is arrangement of electrons. Okay, so we know the structure of an atom. So an atom has what? A nucleus. Then inside the nucleus we have what? Protons and what? Neutrons. Then on the shells we have what? Electrons. Okay, so the orbits or shells of atoms are spheres set around what? The nucleus, on which what? Electrons move. So we are going to have our structure of the atom is going to be the nucleus. Then the nucleus, we have shells around what? The nucleus. So the shells are said to be what? Sphere in nature. Then on these shells we have what? Electrons moving around what? The nucleus. Okay. Okay, so the shells also have what? Names. So the first shell is known to be K shell, the second is known to be L, the third is known to be M, and the fourth is what? The N what? Shell. So they are arranged in ascending order from what? The nucleus. So from the nucleus we have what? The K shell, then move on to the L shell, then we have the M and what? N. Okay, so each of the shells has the maximum what? Number of electrons it can what? Contain. Okay, so the formula used for what? Filling the shells is given by 2n exponent what? 2, where this n is what? Our shell number. So taking for instance K, so our shell number is going to give us what? 1. Taking L, our shell number is going to give us what? 1, 2, and M is going to be 3, and N what? 4. Okay, so now let's take a table to represent how these shells are what? Filled. So we are going to have a shell, we have a letter representation, then maximum number of electrons, then energy. Okay, so our first shell is going to be what? Shell 1. Then the letter representation is going to be what? K. Then the maximum number of electrons it can occupy is what? 2. This is because using the formula 2n exponent 2. For the equation our n is going to be what? 1. So it means we are going to get 2 multiplying what? 1 squared. And 1 squared is what? 1 multiplying 2. So you get our maximum number to be what? 2. Okay. Then you take our shell number, next shell number, which is what? 2. And the letter representation is going to be what? L. So L, the maximum number of electrons it can take is what? 8. Why 8? So let's use the formula to prove it. So in the second shell, it means our n is going to be 2. So we are going to have 2 multiplying 2 what? Squared. And 2 squared gives what? 4 times your 2, which is what? 8. Let's move on to the next shell number, which is what? 3. So 3, the letter representation is going to be what? M. Then M, the maximum number of electrons it can occupy is what? 18. Why 18? So let's prove it using the equation. So the third shell, it means our n is going to be 3. So we are going to have our 2 times. So our n is going to be 3. So we are going to get 2 times 3 exponent what? 2. And 3 exponent 2 gives 9 times your 2. Then we are going to get what? 18. And let's move on to the last shell, which is what? Shell number 4. And our letter representation is going to be what? N. So let's see the maximum number of electrons the N shell can also what? Take. So it means we are going to have our N to be what? 4. So we are going to have 2 times 4 exponent what? 2. 4 squared is what? 16 times your 2. And you get what? 32. So the maximum number of electrons the N shell can also take is what? 32. Okay. Now let's look at the energy. So as the shell number increases, then energy also what? Increases. So we are going to get the energy level to what? Moving this way. Increasing what? Energy. So here, as the shell number increases, then the energy also what? Increases. Okay. So now let's take our next subtopic, which is electronic configuration. Electronic configuration. Electronic configuration. Okay. So under the electronic configuration, here we are going to look at the arrangement of electrons in what? An atom. Okay. So when we take the electronic configuration, it can be represented in 2 ways. So the first way is one, by drawing shells. By drawing shells and representing the number of electrons. In them with bullets. That is dots or with a cross. Okay, so the first way we can represent electrons in an atom is one by us drawing the shells and representing the number of electrons in them with a dot or a cross. So let's take examples under that. So here let's consider the helium atom. So helium atom, we are going to have what? The mass number to be, the atomic number to be what? 2. So here we are dealing with what? A neutral atom. So for a neutral atom, we have the number of protons to be equal to what? The number of what? Atomic number. Sorry, the atomic number. And this is also going to be equal to what? The number of what? Electrons. So in the neutral atom, for helium, when the proton number is 2, it means our electron number is going to be what? 2. So let's look at how to arrange these electrons. Look at how to arrange these 2 electrons on the shells. And at the first what? Arrangement. So we are going to draw our atomic structure for helium. So that is going to be what? Our nucleus. So we know that for helium atom it has what? Only 2 electrons. So representing it, we are going to represent it with what? A bullet. So 1 what? 2. So that is what? How to arrange the electrons on the shell. And at the first what? Arrangement. Let's also take lithium. So for lithium, we know that the atomic number is what? 3, mass number is what? 7. So we are going to have what? Our structure, nucleus. Then the first one is going to take what? 2 with bullets. So the next electron will go to what? The next shell. Okay. So that's how to arrange what electrons on the shells using bullets or what cross. Okay, now let's move on to the second arrangement. Okay, so for the second arrangement, we are going to have it to be by writing the number of what electrons against the shells and separated by what comma. So the next arrangement is what we write the number of what electrons against the shell, then you separate it by what a comma or it's a comma. Okay, so let's take examples under that. So examples, let's take the hydrogen atom. So hydrogen, the atomic number is 1 and the mass number is also what 1. Okay, so for hydrogen it has what only one what electron, and the shell is going to be what the shells in ascending order. We have K, L, M, and what N. So since hydrogen has only one only one electron, it means that electron will go to what the K what shell. Okay, so it means you are going to have what K. Then you write what the number of electrons. So that's how it is what represented. Now let's take our next one. Our next example is going to be helium. So for the helium atom, we have atomic number to be 2, mass number to be what 4. So helium also has 2 electrons, meaning the 2 electrons will also go for what the K shell. We are going to have our K. How many electrons? 2. So K is the first what shell. Now let's move on to another example. We are going to have what? Let's take lithium. So for lithium, the atomic number is 3 and the mass number is what? 7. So for lithium, we are going to have what? Our K shell. So the K shell, how many electrons are we going to have on the K shell? What? 2. Then you'll be left with what? 1. Then the 1 moves to the what? The L what? Shell. So we are saying that you write the number in front of what? So you write the number against the shell. Then you separate it with what? Comma. So 2 electrons for K, then 1 electron for what? L. Then these 2 numbers, you separate them with what? A comma. Okay. Let's take another example. So for the next example, we are going to have neon. So neon, the mass number is what? The mass number is 20. The atomic number is what? 10. So let's look at how to represent neon. Okay, so neon, we are going to have our K shell, which is going to take what? 2 of the electrons. Then you move on to what? The L shell. The L shell is going to take how many? 8. So we have what? 8 what?